We will now evaluate this limit. That is, we have the limit h approaches 0, the rational function 1 minus cos 4h over cos squared 6h minus 1. So let's do the direct substitution over here. In direct substitution, we have to let h approaches 0. So I'm going to put 1 minus of cos of 4 times of 0 over cos squared 6 times of, I'm replacing h by 0 minus 1. So this evaluates to 4 times of 0 is 0. So basically it is cos of 0 divided by cos squared 0 minus 1. We know the value of cos 0 is 1. So this becomes 1 minus 1 divided by 1 minus 1 in the denominator. And this gives 0 over 0. So this is an indeterminate form. And this means we can now apply the L'Hopital's rule, because when we encounter any of the indeterminate forms, we can use the L'Hopital's rule. Suppose the rule says that if a limit f of x approaches a equal to 0, and limit x approaches g of x equal to 0, or limit f of x approaches a plus or minus infinity, and limit g of x approaches a gives plus or minus infinity, then according to this L'Hopital's rule, the limit of the rational function when x approaches a is equal to limit of the f prime of x over g prime of x. So this is basically the limit of the derivative of f of x divided by derivative of the g of x. So we specially use this when we encounter the indeterminate forms like 0 by 0 or infinity over infinity or plus minus infinity over infinity, like this kind of indeterminate forms. So let's apply the L'Hopital's rule here. So if I consider the numerator function as f of x and the denominator part as g of x, then I have to find the derivatives of the numerator divided by the derivative of the denominator. So let me copy the limit over here. That is, we have limit of 1 minus cos 4h over cos squared 6h minus 1, and h approaches 0. So I am using L'Hopital's rule. Let me put it as LH, which means I have to find the derivative h approaches 0. Let me put this. I'm going to find the derivative over here. That is, for the numerator, I write down cos 4h. The derivative of 1 is 0, and derivative of negative cos 4h is negative sine 4h multiplied by 4 when we apply the chain rule. So basically this becomes, we have two negatives here, negative is positive, and then we have 4. So this gives 4 times of sine of 4h. So I can replace the numerator as 4 times of sine of 4h. And let me also do for the denominator. In denominator we have cos squared 6h minus 1. So we have to find its derivative. And this gives, we have to first apply the chain power rule to find the derivative of cos squared 6h. So which means I have to put the power in front, multiply with the reduced power, that is 2 minus 1 is 1. So cos of 6h. Then I apply the chain rule to find the derivative of cos of 6h, which is negative sine 6h. Once again, I apply the chain rule to find the derivative of the 6h, which gives 6. So this is what I get. Now we can simplify this. We have this positive 2, negative 1, and 6. So it is negative 12. I can put this as negative 12 times of. I put this sine 6h in front and cos 6h in the back. Now I can use the trigonometric identity. That is, we have this trigonometric identity sine of 2x. This gives sine x. It is 2 sine x and cos x. So I can solve for sine x. That is sine x and cos x. This basically gives sine 2x over 2. Now I replace x by 6h as well as 6h over here. So then this becomes a sine of 6h cos of 6h. This is sine of, here also I have to replace x by 6h. So this becomes cos of 2 times, I'm sorry, sine of 2 times of 6h over 2. So we get sine of 12h equals divided by 2 equals sine 6h cos 6h. So now we can see this, we can replace this quantity sine 6h cos 6h as this quantity. So I'm going to do that. So therefore this becomes, the reduced form is negative 12 sine 12h over 2. So basically this we can cancel this 12 by 2 and this gives negative 6 sine 12h. So which I'm going to replace it here. That is, we just found the derivative of cos square 6h minus 1. It is a negative 6 sine 12h. So we can do it here. Negative 6 sine 12h. Now once we have found the derivative of the numerator and denominator, we can do the direct substitution. So we let h approach a 0. So in the numerator we get 4 sine 4 times of h is replaced by 0. That is 4h becomes 0 over negative 6 sine of, this is 12h. 12 times of 0 is 0. So now we know that sine 0 is 0. So 4 times of 0 is 0. And sine 0 is 0 in the denominator. So negative 6 times of 0 is 0. So once again we encounter this indeterminate form, which means we can apply the L'Hopital's rule one more time. Let's apply the L'Hopital's rule one more time. First, I'm going to copy this part and find the derivative. So I'm going to copy it down below over here. So we have limit of 4 sine 4h over negative 6 sine 12h. And h approaches 0. So we will find the derivative of the numerator. That is, we have to find the derivative of this as well as the derivative of this denominator. Now we can do it here. This is a limit h approaches 0. Derivative of 4 sine 4h is negative cos 4h, and when we apply the chain rule to find the derivative of 4h, we get 4. And similarly, when we find the derivative of negative 6 sine 12h, I put the constant negative 6 as it is, and then the derivative of sine 12h is uh, cos 12h. I'm sorry, this is positive. It's not negative because derivative of sine is positive quantity. So this becomes cos 12h and then multiplied with 12, because when you find the derivative of this 12h, we will get only 12. So we get like this. Let's simplify this. So this is equivalent to limit of h approaches 0. We have this 4 multiplied with the 4 becomes 16. So cos of 4h. And then we have this negative 6 multiplied with the 12, which is negative 72 cos 12h. Now we can substitute h equal to 0 into this. So this becomes 16 times of cos of 4 times of 0 over negative 72 cos of 12 times of replacing h by 0. So this becomes 16 times of cos 0 is 1, and negative 72 times of cos 0 is 1 once again. So basically this gives a negative 16 over 72. We can do some cancellation over here. We have a common denominator of 8. So this is 2 times of 8, and this is 9 times of 8. We can cancel this common denominator 8. So when you do that, we get negative 2 over 9. And this is the answer for this question or the given limit. We now evaluate this limit. We have limit x approaches 2 pi, natural logarithm of cos x over pi minus x by 2 quantity squared. So first let's evaluate the limit by direct substitution. So we have to let x approaches 0. So we can replace x by 2 pi. So therefore this becomes natural logarithm of cos of 2 pi over pi minus of 2 pi by 2 quantity squared. So this is natural logarithm of the value of cos of 2 pi is 1. So therefore this becomes natural logarithm of 1 divided by, I can do this cancellation with 2 with 2. So it becomes pi minus of pi quantity squared. Natural logarithm of 1 is 0 and pi minus pi is 0. So 0 squared is 0. So we end up with 0 over 0 indeterminate form. And this means we can use the L'Hopital's rule. So let's find the derivative of the numerator divided by the derivative of the denominator. So I put limit x approaches 2 pi. The derivative of natural logarithm of cos x, can do it over here. Natural logarithm of cos x, we find this derivative. So first when we apply the derivative rule for natural logarithm, we put 1 by the function, that is the function over here is the inside part is a function cos x. So we put 1 by cos x and then we have to apply the chain rule to find the derivative of cos x, which is negative sin x. So basically this is negative tan x. So I can write down negative of tangent of x over, and then we have to find the derivative of pi minus of x by 2. Pi minus of x by 2 quantity square, the derivative. So this is equal to, we have to apply the power rule first since we have a power of 2 here. So we put the power in front and reduce the power by 1, that is 2 minus 1 is 1. So therefore this becomes pi minus x by 2. And then we have to apply the chain rule to find the derivative of negative pi minus x by 2. Derivative of pi minus x by 2, pi is a constant, so therefore it becomes 0 minus of derivative of x by 2 is 1 by 2 times of derivative of x is 1. So it's basically reduces to negative 1 by 2. So this could be simplified. We have 2 and 2, these two will get cancelled. I have this negative, so I can write down this as negative of pi minus of x by 2. I'm going to replace it over here. So this becomes negative of pi minus of x by 2. So we now found the derivatives of the numerator as well as the denominator. We can do the direct substitution here. So, and this gives, we let x approaches 2 pi. So therefore this becomes a negative tangent of 2 pi over negative of pi minus 2 pi by 2. Tangent of 2 pi is 0, so this becomes 0, and this negative and negative will get cancelled. And here once again we get pi minus of pi, so once again we get 0 in the denominator, that is 0 by 0. This is also another indeterminate form. So which means we can apply the L'Hopital's rule one more time. Let's have the simplified form. So I'm going to cancel these two negatives. So I'm going to take the limit. The limit as of now as we have a limit of tangent of x divided by pi minus x over 2. Pi minus x over 2, and x approaches 2 pi. So when we apply the L'Hopital's rule, we have to find the derivative of numerator, that is derivative of tangent x, which is secant square x. So I can write down this as x approaches 2 pi secant squared x over derivative of pi minus x by 2 is negative 1 by 2, as we already did. Here we did. So therefore this is secant squared x over negative 1 by 2. Now we can do the direct substitution, and when we do that we let x approaches 2 pi. So this becomes secant squared of 2 pi over negative 1 by 2. We know the value of secant squared 2 pi is reciprocal of cos squared 2 pi. Cos 2 pi is 1. So 1 squared is 1. So basically this becomes 1 over negative 1 by 2. And this is equal to 1 multiplied by negative 2 by 1. So this gives negative 2. So the value of this limit is negative 2. Let's evaluate this limit. We have limit x approaches 0, 4 power x minus 3 power x divided by x. So when we do the direct substitution, we get 4 raised to the power of 0 minus 3 raised to the power of 0 divided by 0. 4 raised to the power of 0 is 1, and 3 raised to the power of 0 is also 1 divided by 0. So we get 0 over 0, which is once again an indeterminate form. So we can use the L'Hopital's rule. So let's do that. So we have a limit of 4 power x minus of 3 raised to the power of x over x approaches 0, and this is equal to, we have to find the derivative of numerator. So let me find it here. For this, I'm going to use the derivative formula for a power x. So a raised to the power of x, and if you find the derivative according to the derivative rules, this is a raised to the power of x and then natural logarithm of a. So for our problem, we have 4 power x raised to the power of, that is, we have to find the derivative. So this is equal to 4 power x natural logarithm of 4. And similarly, derivative of 3 power x is equal to 3 raised to the power of x natural logarithm of 3. So we can substitute it over here. So therefore, this becomes, let me write down below. So this becomes 4 power x natural logarithm of 4 minus 3 power x natural logarithm of 3, and then the derivative of x in the denominator is 1. So we can put the limit. So this is basically limit x approaches 0. Now we have found the derivative of numerator and denominator. We do the direct substitution. Let's do the direct substitution. And when we do that, we get 4 power 0 natural logarithm of 4 minus 3 power 0 natural logarithm of 3 over 1. 4 power 0 is 1. So this is 1 times of natural logarithm is natural logarithm 4, and 3 power 0 is 1. 1 times of natural logarithm is 3. So this is natural logarithm of 3. So divide by 1, so we do not have to write down. So when we use the property of logarithm, this is using the property, if we have log of a, natural logarithm of a minus natural logarithm of b, this is equal to natural logarithm of a over b. So therefore, we can write down this in simplified form as natural logarithm of 4 over 3. And this is the answer for this question. Let's evaluate this limit. So we have limit x approaches 0, 2x over 5 minus of square root of x plus 25. So first I'm going to do the direct substitution, and when I do that, I will be getting 2 times of 0, replacing x by 0, and in the denominator we have 5 minus of 0 plus 25 under the root. So this reduces to, numerator is 0, 2 times of 0 is 0, and this becomes 5 minus of square root of 25, which is 5. So once again we are ending up with 0 over 0, which is indeterminate form. So we can apply the L'Hopital's rule. So let me do that. So we have to find the derivative of 2x as well as the derivative of uh, 5 minus of square root of x plus 25. So I put limit of x approaches 0. Derivative of 2x is 2, and divided by, let me do the derivative of 5 minus of x plus 25 over here. It is under the root. So here we have to find the derivative of 5, which is 0, minus derivative of square root function. This could be written as x plus 25 raised to the power of 1 by 2, and we have to find the derivative. So let's do that. So this is equal to, we have the negative already. I put the power in front and then reduce the power by 1. So this becomes x plus 25 raised to the power of 1 by 2 minus 1. This is equal to negative 1 by 2. So this is negative 1 by 2. Now this could be simplified and written in positive powers as negative 1 by 2 times of 1 by x plus 25 raised to the power of positive 1 by 2, which could be written as square root of x plus 25. So basically the derivative of 5 minus square root of x plus 25 is this quantity, negative 1 by 2 times of 1 over x plus 25. I'm going to replace it over here. It is for the denominator, I'm going to replace it as negative 1 by 2 times of 1 over x plus 25 under the root. Now we have found the derivatives of numerator and denominator, which means we can do the direct substitution. So let's check if you are getting the result. So the numerator, we just have 2 as a constant, and in the denominator we have negative 1 by 2 times of 1 over x. In place of x, I put 0. So therefore this becomes 0 plus square root of 0 plus 25 square root. So we can simplify this further. So this is equal to 2 over negative 1 by 2 times of 0 plus 25 is 25, and square root of 25 is 5. So basically this is 1 over 5, or else we can write down this as 2 over negative 1 by 2 times of 1 by 5. The denominator gets multiplied, so it becomes negative 1 over 10. Now we can multiply by the reciprocal of the denominators. So this becomes 2 times of negative 10 over 1, which is negative 20. So this is the answer for this question.